Everyone, here's JJ. So this video I will explain the question from the past paper. Okay, so let's go. Let's read first question. So consider the arithmetic sequence U1, U2, U3 arithmetic sequence. The sum of the first n terms of this sequence is given by Sn equal n squared plus 4n. Then the first question asks us to find the sum of the first 5 terms. So because we already know the sum of first n terms of the sequence is given by this formula, therefore we just have to put 5 in the formula. Therefore, we know that IS5 is equal to 5 squared plus 4 times 5, which is 45. Right? Then, given that S6 is equal 60, then we try to find U6. I mean, actually we don't have to, how to say that? We don't have to, so we don't need this information that S6 equals 60. It's because if we put 6 in the formula and we calculate by ourselves, we can also get S6 is equal to 60. But this question gave it to us. So how can we find U6? Let's think about this. So according to the definition, Sn, it means we add U1, U2, then U3, then add everything till Un, right? So according to this definition, Sn minus 1 should equal to U1 plus U2 plus U3 plus till Un minus 1. Why do this? Because let's see, if we use the equation above minus the equation like at the bottom, so we can get Sn minus 1 is equal to, C. To here. Those parts are exactly the same. Therefore, there will be only Un at the right side of equation. Therefore, we know that Un is equal to Sn minus 1. So, by this equation, we know that U6 is equal to S6 minus S5. Does that make sense? Therefore, we already know S6 is equal to 60, and we know S5 is equal to 45. So we know that U6 is equal to 15. It also makes sense, right? The question B is also really tricky because it seems here's no, they didn't tell us how much is U1. How can we get U1? Let's go back to the definition of Sn. Sn, it means the first n terms of this sequence, right? So let's think about S1. S1 means the first one term of this sequence. So S1 should equal to U1, right? And we know how to calculate Sn. Therefore, we know that S1 is equal 1 squared plus 4 times 1 is equal to 5. Therefore, U1 is equal to 5. Then question C. Hence or otherwise write an expression for Un in terms of n. Here's two ways to do that. So first, let's do it by hence. Hence write an expression for Un in terms of n. It means we should try to use the result we got in question B to write an expression for Un. Therefore, we know that U1 is 5. And we already know how much is U6. And we know U1 is equal to 5. Therefore, we know that D is equal U6 minus U1 divided by 5. Why? Because from U1 to U2, we plus 1D. 2 to 3 plus 1D. 3 to 4 plus 1D. 4 to 5 plus 1D, 5 to 6 plus 1D. Therefore, in total, there's 5D between like U1 and U6. Therefore, if we use U6 to minus U1, then we will get 5D, then divided by 5, we can get D. So, U6 is 15, U1 is 5, then D is equal 10 over 5, which is 2. Therefore, we can calculate, we know that wait, not S. Oh no. Disappear. And we know that Un is equal U1 plus n minus 1 D is equal to 5 plus n minus 1 times 2, which is 5n. 5 plus 2n minus 2. So 3 plus 2n. We could check when we let n equal 1, put back to the formula. 3 plus 2 times 1 is 5. When we put 6 into the formula, 3 plus 2 times 6 is 15. So it's correct. And here's another way. Let's observe the thing we do here. You see, we can calculate Un by using Sn minus 1. So we know that Sn is equal n squared plus 4n. Sn minus 1 is equal to something like that. Let's open the bracket and just calculate. So we get n squared plus 4n minus n minus 1 squared plus 4n minus 1. Here's an easier way to calculate it, that we don't have to expand this, because it's really disgusting, right? So that we can use n squared to minus n minus 1 squared. Why? Because it's something like a squared minus b squared. We can use a formula to factorize it. So we get n plus n minus 1 time n minus n minus 1 with a bracket, be careful. And then 4n minus 4 times n minus 1 is equal to 4. If that makes sense. Then let's simplify this. N plus n minus 1 is 2n minus 1. N minus bracket n minus 1 is 1. So it's nothing. Therefore, we get 2n minus 1 plus 4. So we get 2n plus 3. The result is exactly the same. 2n plus 3, 2n plus 3. So we get the answer, the expression for un in terms of n. Oh my god. This whiteboard is a little bit dirty. So, right now let's talk about question 2. And later we will do question 5 immediately because those are pure algebra, I would say. Like simple algebra compared to other questions. So, first of all, we have to expand this. This one is easy. I mean, you can just draw a Pascal triangle. Do we know that? 1, 4, 6, 4, 1. Then let's expand it. We get 1 to the power of 4 plus 1 to the power of 3 times 1 over x times 4 plus 1 to the power of 2 times 1 over x to the power of 2 times 6. Then continue. Then simplify this, we can get 1 plus 4 over x plus 6 over x squared plus 4 over x cubed plus 1 over x to the power of 4. That's it. Then let's talk about question B. Hence, determine the exact value of 1.1 to the power of 4. So, if you want to show, oh teacher, I'm good at calculating, then you calculate 1.1 times 1.1 times 1.1 times 1.1 by hand, you are this. So, let's observe this number, 1.1. Because it said hence, so we should try to find the relationship between 1.1 and the stuff here. Okay, so we know that the question asks 1 to the power of 4. And the thing we get here is something like 1 plus 1 over x to the power of 4. So to the power of 4 is something common, and both of them have a 1. So the only difference is this 0.1 and 1 over x. So, but the thing is, we know that 0.1 is equal 1 over 10. 1 over 10 and 1 over x is similar. So, the thing is, if we let x equal 10, then 1 plus 1 over x is to the power of 4 is equal 1 plus 1 over 10 to the power of 4, which is 1.1 to the power of 4. And we already expand this, so we can just put 10 to here, then we can get 1.1 to the power of 4 should equal 1 plus 4 over 10 plus 6 over 100 plus 4 over 1000 plus 1 over 10,000. Then we can get 1.4641. It's really interesting, right? 14641. It's same as the coefficient of binomial expansion when n equals 4. So interesting, right? I will explain something about 11 later, something like 1.1, because it's also really interesting. Then let's do question 5. During the math class, many of my friends, they are confused about this question. Oh, what should we do about both sides? Because one side is something to the power of something about x, and another side is also something to the power of about x. We cannot solve it, right? It seems that we cannot solve it, but let's observe this equation. The question asks us to solve the equation, which means find x equal to what? And we know how to solve x when it's a polynomial equation. For example, 2x plus 3 equals 6, or x squared plus 3x plus 2 equals 0, or it can be also fraction, something like 1 over x minus 2 equal 2. So how much is x? But so, anyway, we should try to transform those kind of equation to the equation that we know how to solve. So in this case, we should use ln. Okay, ln, ln, okay? Ln 8x minus 1, 8 to the power of x minus 1, and ln 6 to the power of 3x. Before we continue, let's continue to simplify both sides. So we know that 8 is equal 8 is equal to the power of 3. And we know that 6 is equal to 2 times 3. Oh wait, sorry. Actually, right now we cannot simplify it, or we can simplify it later. But I just want to remind you guys the relationship between 8 and 2 and the relationship between 6 to 3. Because you see in the question, it said express your answer in terms of ln 2 and ln 3. So it may be useful when we continue solving the equation. Okay, so according to the formula that ln a to the power of b is equal b times ln a. If you forget how did we get this equation, check my video in the past, last year. So we know that left side is equal x minus 1 times ln 8. Another side is equal 3x times ln 6. Oh, be careful, here's x, sorry. Then let's expand it. Ln 8x minus ln 8 is equal 3 ln 6 times x. Then try to solve the equation, move it here. So ln 8 times x minus 3 times ln 6 times x is equal to ln 8. And right now we can continue to simplify the ln stuff like this. So ln 8 is equal to ln 2 to the power of 3, which is equal 3 times ln 2 x minus 3 times, so because 6 is equal to 2 times 3, so ln 6 is equal ln 2 times ln 3. Wait, ln 2 plus, sorry, because 6 is equal to 2 times 3, therefore ln 6 is equal ln 2 plus ln 3, my bad. X is equal to 3 ln 2. Both sides have a common factor 3, therefore we can cancel them out, make everything simplified. And see, ln 2x minus ln 2 plus ln 3x, then we get yes, negative ln 3x is equal to ln 2. Therefore, at the end we get x is equal to ln 2 over ln 3. Okay, negative. Does that make sense? So in this question, we use this formula, use the equation that ln a to the power of b equal b times ln a, but also we use ln a times b is equal ln a plus ln b. So that's why we should review the thing we learned in the past. So this is question 2 and this is question 5. Good, right? Let's continue question 3 and question 4. So question 3 said, when the polynomial 3x cubed plus ax plus b is divided by x minus 2, the remainder is 2, and when divided by x plus 1 is 5. Find the value of a and the value of b. Do you guys still remember how can we use information of the remainder and the thing we divided by? I mean, so we know that the remainder means if we use this to divide by x minus 2, then we will get something here, then something time, then we will get something plus 2 over x minus 2. And when we use this to divide it by x plus 1, then we will get something blah 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 plus 5 over x plus 1. Those stuff is called remainder, and right now let's time x minus 2 for both sides of equation 1 and do something everything similar for the equation 2. Yeah, I tried to explain what can we do faster in the future for those kind of questions. How can we do those questions faster in the future? So we time x minus 2 for both sides and we get 3x cubed plus ax plus b is equal to something times x minus 2 plus 2, right? And the same, 3x cubed plus ax plus b is equal something, obviously it should be something different, times x plus 1 plus 5. So let's observe both sides of those two equations. For the left side, here's not here we can do nothing for left side, but for the right side, let's see. We don't know what's that, right? But the thing is, if we let x equal 2, doesn't matter how much we will get here, but 2 minus 2 is equal to 0. Therefore, we will get everything here will be 0, and we will get 2 left. So it means when x equal 2, we know that 3x cubed plus ax plus b should equal to 2. The 2 here. So, and we can do a similar thing for this one. If we let x equal -1, doesn't matter how much is this, those stuff will become 0. Then we know that when, oh my god, when x equal -1, whole stuff should equal to 5, because here's only 5 left at right side. Then let's simplify those stuff. So we get 2 to the power of 3 is 8. 3 times 8 is 24. So 24 plus 2a, ax, so 2a, plus b is equal to 2. And for here, -1 to the power of 3 is -1. So it will be -3 plus, minus a plus b is equal 5. And we can just solve this system. I mean, it's not that hard to solve it, right? By yourself. Okay, I can show you guys. So yeah, both left side have a b. Then it's easy to just make b disappear. Then left side minus left side, right side minus right side. Then we get b disappeared. 2a minus -a is 3a. 24 minus -3 is plus 27. 2 minus 5 is -3. Therefore, 3a is equal -30. A is equal -10. And yeah, then we can get b is equal to 2 actually. That's it. So it means in the future, when you solve this kind of question, is you can just, for example, in this case, x minus 2, then you know that you can let x equal to 2. Then you can let x equal to 2 and put it back to here, and this thing should equal to the remainder 2. And similar here. Let x equal to -1, put it back to here, and this thing is equal to remainder 5. Then you just solve the system to get how much is a and b. So that's it. Cool, right? Then let's do question 4. So we get the equation that like that here. And we know that the root of the equation are R1, R2, R3. Then we know that R1 plus R2 plus R3 plus R1 times R2 times R3 equal to 0. Then find A is equal to what? Wait, let me get green pen. First, let's observe this stuff. What is R1 plus R2 plus R3? Yes, the sum of the roots is sum of the roots. What is R1 times R2 times R3? It's the product of the roots. So let's use formula booklet. Then you can find that the sum of the roots is equal to negative an minus 1 over an. And we know it is sum. Okay, I prefer use sigma. Sigma is equal to this. We should and the product I prefer use this sign. You guys can ask ChatGPT why I use this two sign. This sign is sigma. This sign is is capital of pi is equal to minus 1 to the power of n times a0 over an. So let me show it. But guys, before you try to put everything into the formula, let's check the equation. When we use these two formula, we have to make sure that the equation is like blah 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 equal to 0. But guys, see here, there's a at right side, so we should move the a to left side. So the new equation will be like fx cubed plus 48x squared plus 100x plus 2 minus a equal to 0, and 2 minus a, the whole thing is a0 in this case. Really be careful about it. Okay, then we know that sigma is equal to negative 48 divided by 5. And we know that the pi is equal, so in this case, n is 3, right? Because cube. And we know that, so negative 1 to the power of 3 is negative 1. So let's continue. A0 is 2 minus a. 2 minus a over the an 5. Let's put in everything. Use those stuff to replace the sum and product. So we know that negative 48 over 5 minus 2 minus a over 5 is equal to 0. And yeah, move it here. So we know that. I mean, we can simplify it. I won't show, I will explain because it's a little bit confusing if I just skip it. So move this term to here. Then we get negative 2 minus a over 5 equal to 48 over 5. And this negative in front of the fraction, we can time it inside. Then we can get a minus 2 over 5 is equal 48 over 5. Both sides times 5. A minus 2 is equal 48. Therefore, a is equal 15. And guys, I will explain questions 6, 7, 8 together because those questions are all relatively simple. The last two questions. So let's go. So consider the complex number u equal 2 plus 3i and the v equals 3 plus 2i, given that blah 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 blah, express w in form of a plus bi. Ha. So actually, you guys might realize that like u and v looks really similar, but they are not conjunction to each other. Conjunction complex number to each other, right? I mean, one is 2 plus 3i, one is 3 plus 2i, and you see the equation here is 1 over u plus 1 over v is equal to 10 over w. Because the thing is, if we change the position of u and v, nothing changed. It's like it's exactly the same. So let me show you guys how did I do that. So we try to express w in form of a plus bi. So let's start it with this equation. Is this that makes sense? Try to find the common, the smallest, what I call smallest common. Smallest common. Okay, let's keep it. is equal to 10 over W. And then we can, okay, the thing is, if A over B is equal to 3 over D, obviously B over A is equal to D over C. Does that make sense? It's just like you rotate yourself like 180 degrees, like that. And therefore, we can find something like that. Therefore, W is equal 10 times UV over U plus V. And, okay, so U is 2 plus 3I, V is 3 plus 2I, and C. Let's see. U plus V is 2 plus 3 plus 3I plus 2I, which is 5 plus 5I. And the thing above is 10 times 2 plus 3I times 3 plus 2I. And guys, look at this. There is a 10 above and bottom we can write as 5 times 1 plus I. Therefore, we can cancel that out. We get 2. Then we get 2 times this 2 things time together over 1 plus I. And look at here. You see, 2 plus 3I times 3 plus 2I is equal to 2 times 3 is 6. 3I times 2I is 6I squared, which is negative 6. 2 times 2I, 4I. 3I times 3, 9I. 6 minus 6 is 0, then we get 13I. But it seems we still have to divide it, use this thing to divide this, right? But the thing is, it's really interesting because 1 plus I times 1 minus I is equal to 2. Yeah, I mean, it's not that obviously, but it seems really relatively obviously, right? It's equal. You can check. So it means 1 minus I is equal to 2 over 1 plus I. Therefore, we know that the stuff here is 1 minus I. Then we get, so everything is, W is equal 1 minus I times 13I, which is, okay, 1 times 13I is 13I. Negative I times 13I is negative 13I squared, which is 13. So the answer is 13 plus 13I. Really interesting, right? Wait, sorry. I will check my storage if it still works. Good job. Okay, I come back. Good Morgan. It's still Morgan. Question 7. The function f is defined by fx equal 1 over x does not equal to 0. And the graph of function y equal gx is obtained by applying the following transformation to the graph of y equal fx. Blah blah blah. Translation by vector. Translation, okay. By vector this. Translation by vector 0, 1. Fx is equal to 1 over x. Then find the expression gx. So the first translation is like move to, how to say that? So for this translation is horizontal translation, and because it's -3, so it means we have to translate the graph to left 3 with 3 units, right? Translate 3 units to left. So it means from here to here, the thing we should do is use x, like the thing inside the bracket should be this. So which is equal 1 over x minus -3, which is 1 over x plus 3. And then the second translation is translate the graph 1 unit to upward. So we should +1 outside of F1. So it means therefore we get gx. It's like that. So we know that gx is equal 1 over x plus 3 plus 1. So this question is just like basic the way to translate the graph of function like that. So remember, horizontal translation plus or minus inside the original function. Translate the graph like up or down, you should add or minus something outside the function. I don't know if you guys can understand this point, because you see, when we translate the graph horizontally, we do something inside the original function fx, that's why it's x minus -3. But when we translate the graph up and down, you plus 1 outside of the function here. You guys understand? Okay. And state the equation of asymptote of graph gx. I mean, for this question, we can just really draw one. Here's 2 ways. We can just draw one. So original graph is like that, right? And we move left 3. So we can just take care of the asymptote, because when we translate the graph, the asymptote will also translate their position. So the original vertical asymptote is x equal to 0. The horizontal is y equal to 0, and we know that this asymptote move 3 units to left, it will become x equal to -3, and this asymptote move upward, it won't change. So the vertical asymptote is x equal to -3, and it's same for the horizontal asymptote. The horizontal asymptote y equal to 0, so it move 3 units to left, nothing changed, and move upward 1 unit with 1 unit, so like up. So the horizontal asymptote is y equal to 1. So that's it. But also you can just observe this thing. The answer is already there. So if you saw a function like a over bx plus c plus d, if fx is equal to this, then always the horizontal asymptote will always be y equal to d, and the vertical asymptote is always x equal negative c over b. Because here's a d here, it means those stuff can only more than 0 or less than 0, but not equal to 0. So the asymptote will be y equal to d. And horizontal, so it just let bx plus c equal to 0, because the thing at the bottom of fraction cannot be 0. So we just let bx plus c equal to 0, then solve it, then we get x equal negative c over b. So that's it. So we can get y equal 1. X plus 3 is equal to 0, so x equal to negative 3. That's it. Oh, here's not enough space for me to do question 8. But right now, let me check the storage. Cool, it's still there. But boy, let me clean the middle part of the. Oh no. Unbelievable. This stuff is really helpful to clean the whiteboard. Unbelievable. Let's continue. The function f is defined as fx equal to e to the power of 3x plus 1. The first question asks us find the inverse, the state domain of the inverse. It's something we all like. So fx equal to e to the power of 3x plus 1. Now, so we use x to replace fx and use y to replace x. So we get x is equal to e to the power of 3y plus 1. Oh, e usually disappear. E. So let's use ln. So ln x is equal to 3y plus 1. And 3y is equal ln x minus 1. So y is equal ln x minus 1 over 3. Oh yeah, that's good. So let's continue. State the domain of f inverse. We all know that the domain of ln x is x more than 0. So if we want to make this stuff, if we want this stuff to make sense, it means the x should more than 0. Because if s is equal to 0 or less than 0, ln x does not exist. In real number. So it means, yeah, the domain of f inverse is x more than 0. Oh boy. The function g is defined as gx equal ln x, the graph of y equal gx, and the graph of y equal inverse fx intersect at point P. So what can we do for this question? First, we have to think about what does intersect mean. So, for example, here, it is fx, it is gx. When two functions intersect at one point, it means, for imagine that if this point is A common B, it means when x equal A, then fx is equal to gx is equal to b. Do you guys understand? Intersect of two two graph of functions, it means when x equal to x coordinate of this point, the output of both functions are same. So it means the graph of y equal gx and the graph of inverse fx intersect at point P. So we can just let these two functions equal to each other. I don't know if you guys understand what I mean. And let's continue. Ln x minus 1 over 3 is equal ln x. Then continue. Ln x minus 1 equals 3 ln x. Therefore, negative 1 equal 2 ln x. Ln x is equal to negative 1 over 2. Therefore, x is equal e to the power of negative 1 over 2. Then we get x coordinate of the intersect. The point P. Then if we want to get the y coordinate of point P, we can just put the x back to any of the function. Question. Which function should I use to put x back to it? I don't know if you guys understand what I mean. So should I put e to the power of negative 1 over 2 to this function or this function? Which one is easier? Yes, I think you get the correct answer. We should put x equal to e to the power of negative 1 over 2 to ln x. Why? Because, come on, we have to put it back to here and minus 1 and divide by 3. And when you make a mistake, for example, I'm not sure if it is minus or plus. Sometimes, for example, when you make a mistake, you randomly write a line. Oh, it's plus. Then you will lose your point. So the safer way is put x equal e to the power of negative 1 over 2 to here. Then we get 1 is equal negative 1 over 2. So the point P is e to the power of negative 1 over 2 common negative 1 over 2 comma. Okay, that's it. Wow, unbelievable. I just realized that question 7 and question 9, there's something similar. So, okay, write down the equation of the vertical asymptote, write down the equation of the horizontal asymptote for the function fx. So, right now I will show you guys what I mean in question 7. Okay, so fx is equals 2x minus 1 over x plus 1. Do you guys remember I said if you guys can transform this to something like something a over bx plus c then plus d, then we can get asymptote immediately. So how can we transfer this to this? Look at this. 2x. I have a question. What's the coefficient of x at top? Is 2. The coefficient of x at bottom is 1. So 2, 1. And what's the the constant term is 1. So we hope the bottom should have a 2. I don't know if you guys understand what I mean. So then maybe you guys can understand what I mean. I want to find I want to create some condition to help us simplify this to something like that. But let's continue first. So it's equal to 2 times x plus 1 minus 3 over x plus 1. So it's equal to 2 minus 3 over x plus 1. I mean, guys, also this here's another way to explain let's go back to the question 3 about remainder. So actually we can just let x equal -1. We put -1 to here, then we get -3. Then we know that the thing here should be -3. So interesting, right? Think about it. Use remainder. I write it down. Think about why we can do something like that. So continue to here. So we know that the horizontal asymptote is y equal to 2, and the vertical asymptote will be, okay, let x plus 1 equal to 0. So we know that x is equal to -1. So that's it. We get the asymptote. And on the set of axes below, sketch the graph. You guys can do it by yourself. I believe you guys. And then, using the graph, if you calculate the intersect correctly, then you can get, for the question C, you should get wait guys, listen. You should get the answer should be x more than 1 over 2. And then the question D looks really complicated because here's absolute value. But here's two ways to understand or solve this inequality. First way, the inequality in question C, the thing between 0 and 2 is function fx, right? And for the question D, we just use absolute value of x to replace x, so we have to solve something like that, right? So this thing is fx, so therefore, then what's that? Yes, it is absolute value of x. Then, if you sketch the graph of fx, then you can sketch the graph of absolute value of x by reflect the graph at right side to left. Then so it's like you reflect it. Then you can use the graph to know the answer. The answer should be x more than 1 over 2 or x less than -1 over 2. And here's another way to understand the question. So, let k equal absolute value of x. Then we get 2k minus 1 over k plus 1 is more than 0 and less than 2. This two inequality is exactly the same, right? They just use different letter. Therefore, we know that if we know the answer of this inequality is x more than 1 over 2, then we know that the answer of this inequality should be k more than 1 over 2. And because k is equal absolute value of x, therefore absolute value of x is more than 1 over 2. Let's draw a graph. Draw a line. Absolute value means the distance of the number and 0, between the number and 0. So absolute value of x more than 1 over 2, it means the distance between the number and 0 is more than 1 over 2. So therefore, the answer should be, there's empty, we must be careful, this is empty. It is 1 over 2, this one is negative 1 over 2. The answer should be like that. Therefore, x is more than 1 over 2 or x less than negative 1 over 2. That's it. Really tricky, right? I think the one here is really tricky. I mean, haha. Because the battery of my phone ran out, therefore the video for question 9, it didn't record it successfully, so sorry. So I will explain it. So for the question A, is similar to the question 7, the thing I mentioned for question 7, and also is related to question 3, my method. So we can use the method we use for remainder, that. So we let x plus 1 equal to 0, then we know x is equal to negative 1. We put negative 1, use negative 1 to replace x. Then we calculate the remainder of this should be negative 3. That's why the thing above, the bottom, the stuff here should be negative 3. And therefore, we can rewrite this like 2x minus 3. How do you make 2x minus 3 equal to 2x minus 1? Yes, plus 2. Then we realize something like that. 2 times x plus 1, bracket, okay, minus 3, or x plus 1. Then continue to simplify it, we get this. And use the, how to say that, use the conclusion. We know that the vertical asymptote is when bottom equal to 0, so x equal negative 1, and horizontal asymptote is 2, y equal 2. And then for question here, if you draw the graph correctly, calculate the intersect correctly, then you can get the answer is x more than 1 over 2, right? But what about question D? Here's two ways to understand question D and solve it. First, we know that the thing here between 0 and 2 is fx. And the thing here is similar to this, but what's that? Yes, if it is fx, then it is f of absolute value of x. Therefore, the graph of this function should be the graph at right side reflect to the exactly the same one to the left side. Then according to the graph, you can see the answer should be x more than 1 over 2 or x less than negative 1 over 2. Or here's another way. Let's let k equal to absolute value of x, then we get an inequality like that. These two inequality is exactly the same, we just use different letter. So if the answer of this inequality is x more than 1 over 2, then the answer of this inequality should be k more than 1 over 2. K is equal absolute value of x. Therefore, absolute value of x more than 1 over 2. Let's use this line, the real numbers, this line to explain it. Absolute value of a real number, it means the distance between this number and 0. So the distance between this number and 0 is more than 1 over 2. So it means this number is more than 1 over 2 or less than negative 1 over 2. So the answer is that, exactly the same. So there's two methods. And this method is using graph to see the answer, and this one is use pure algebra. This interesting ideas. Yeah. I found this idea by myself. Yeah. And guys, finally, last question. Oh, not the last question. Here's still question 10. Okay, question 10 is also easier. Let's see. Look at this. Fx is equal to negative x squared plus 4x plus 5, and gx is equal to negative fx plus k. First question, let us describe the set of transformations that maps the graph of f onto the graph of g. Therefore, we can analyze one by one. First, we time a negative 1 to the fx, so it's a reflection over x-axis. Then plus k. Plus k is outside of this function, so it's a vertical translation. So the vertical translation of k units. Okay, then let's do question B. Find the value of k so that gx equals 0 has no real roots. Listen, no real roots. It's a keyword. When you listen to that word, do not think anything else. Write that down. Listen, no real roots, no x intersect, it always means delta less than 0. Discriminant. Is that discriminant? Is that called discriminant? I forgot, sorry about it. So delta less than 0. So let's put everything back to here. Then let's see what is delta. A negative of fx plus a k. Then you just reverse all the sign. X squared minus 4x minus 5 plus k. So the delta is equal b squared negative 4 squared minus 4 times a, which is 1, times c, which is k minus 5. So we get 16 minus 4 times k minus 5, which is, let me check, sorry. 16 minus, we can expand it. Actually, we don't have to expand it. Why? Because we are solving an inequality. Less than 0. Both sides, we know that here's a common factor 4. So divided by 4, we get 4 minus k minus 5 less than 0. Then we get 9 minus k less than 0, then k more than 9. It's the answer. So question 10 is something like, first question is about describe the transformation of function. So question B is something about discriminant. So guys, really, finally, we achieved the final question. So sketch the graph of y equal x over 2 plus 1 and y equal absolute value of x minus 2. Minus 2, this is minus 2. Why? If the question is, and because you guys can check the mark scheme. On the mark scheme, the answer is based on absolute value of x minus 2. But also, if you draw a graph of absolute value of x plus 2, then you will see there's only one solution when these two are equal to each other, which is x equal to negative 2. If it's like that, it's so boring, right? It's not like, the math test shouldn't be that easy, right? Therefore, just sketch the graph. The graph should be like that. This intersect is like a 2. Okay, you guys know that. And then we can, there's 1, there's also 2. There will be a line. straight line. So the question asks us to solve the equation of this. Yeah, somebody tried to find the answer on the graph, but sometimes humans' eyes not that powerful. Therefore, we cannot see the answer immediately. So how can we solve it? Here's two ways. Here's two situations for the absolute value of something. Remember of this. When a more or equal to 0, absolute value of a is equal a. When a is less than 0, the absolute value of a is negative a. Do you guys remember this? Why? Because it's a positive number, the absolute value of positive number is itself. If it is a negative number, because we want to know the distance. So the distance from a negative, for example, negative 3 to 0 is same as the distance between 0 and 3. Therefore, absolute value of a negative number is their opposite. Is equal to opposite, like that. So here's two situations. One is like that. Or right? Then we just solve these two equations and we can get the answer. So so one answer should be, oh my god. One answer should be x equal to 6. One answer should be x equal to 2/3. And another way to do that, look. Absolute value of a squared is equal to a squared if a is a real number. It's also something you can find here. The thing is, absolute value of a, doesn't matter if a is more than 0, equal to 0, less than 0. Absolute value of a squared is equal to a squared when a is more than or equal to 0, or is equal to negative a squared, and negative a squared is also a squared, so it's always equal when a is a real number. That absolute value of a squared is equal a squared. Therefore, we can square both sides of the equation, then we get this. No, we should write a step. This square is equal to this square, which is equal to this square. Then expand it, solve the equation, then that's it. So that's all the question on the paper, and I hope you guys can learn something, or my video can help you guys solve some question like in your mind. So good luck and enjoy your weekend. Thank you for watching my video. See you next time.